Okay, so we're gonna take this aldehyde and we're gonna turn it into damn, we're gonna form it into enamine, not a imine, enamine. Okay, really simple. If you have your amine, if you look at your amine, if it has two hydrogens, you're gonna make an imine. If you look in our example right here, we have two hydrogens. We're gonna form into an enamine. My bad. I don't know what I said before. If you have two hydrogens, it goes enamine. So it's really the same thing. Since we have HCl, we're gonna end up protonating it. So this we're gonna have this protonation, and so we're under acidic conditions. So no negative charges. So make your oxygen attack the hydrogen, and bam, we're good. First step, acid base. we're gonna activate we're gonna activate the basically we're increasing oxygen. Oh, this is not right. See, I'm looking at it and I was like, oh, that's a negative charge. Oh, we can't even make it. So even when I made a mistake like that, so this would be like that, and then this should have an extra. No, this is double bond here. Okay, we're good here. Okay, bet. So now we're gonna form resonance structure. So we have a delocalized charge, so we can form resonance. So push electrons, so push that there onto the oxygen. So now we have this carbon. So now like this aldehyde or whatever, this whole thing. I don't know if it's aldehyde anymore. It's aldehyde, yeah. It's like an activated, right? It's reactive, and it's reactive as hell. So now this amine, the secondary amine, is gonna attack it right here. So let me just draw it. I don't know if I could draw it correct. Yeah, this should be good. Yeah, we good. So imine's gonna attack right at the middle, and we're gonna form this amine. Now is gonna be a little bit protonated. I mean a little. I don't know what I mean by a little bit. It's gonna have a charge. Okay. So now we're gonna have to get rid of that charge. So what do we have in the flask? We have the secondary amine, right? So that's gonna, it's gonna deprotonate it right here, bond on the nitrogen like that. Okay, good. I know it's a little bit messy. I'm gonna try to be more clean right now. All right. Okay, bet. Let me just draw it right here. The structure. We have is that a yeah? This is a hydrogen. Yeah, I should have wrote it right. And hydrogen, and this is I'm gonna draw the thing now as this. I'm gonna draw the hydrogen, whatever. Who cares? Okay. Now we're gonna want to get rid of the alcohol. So what we're gonna do is we're gonna make it into a good leaving group. So um, yeah, so when this took the hydrogen, now it's protonated, right? So now it has like a charge on it. So it doesn't have a charge. I don't know why I'm bugging, but yeah, it has a charge on it. So this alcohol is now gonna attack this, and right now it's not a good leaving group. This always won't leave on its own, and even if it left on its own, we will form a negative charge. So it'd be wrong. I mean, we can't have negative charges in acidic conditions. So basically, you cannot have a negative charge in this like ever. So that's why you have to make it pronated so then it could leave on its own. So there's like two reasons why. I mean, you could use any reason, but those are the two main reasons. So this leaves, and now we're gonna end up forming a carbocation on the carbon itself. So damn. So if I draw it like that, let me just draw it correctly. Yeah, this is the structure, and then that is the hydrogen here. Okay, now what do we do? How do we get, we obviously need to make an enamine, right? How do we get the okay, right here there's a charge. So right now, how do we make the let me clean it up. How do we make this molecule neutral? Okay, in previous examples on step 6, I don't know what step we're on right now. This is step one, two, three, four. Okay, so what we're gonna do is we're gonna show so like let's say we move this right here, then it's not gonna help us because if we move that there, then this is gonna have a plus charge, and it was gonna have a plus charge, and how are we gonna get rid of the plus charge there? You can't. There's no hydrogen. So this is why it's important to realize that this doesn't have no hydrogens to give up. So what we're gonna do is we're gonna do beta elimination. So you find um this is alpha and this is beta, and this beta has a hydrogen to give up. So has a hydrogen. So the nitrogen or the amine is gonna deprotonate it. No, it's gonna take it, and then we're gonna do elimination. right here. So now we're gonna form an enamine. Like you know how the alkene is an ene, so we have the enamine, and right here, and this should be the answer. And we have to reform the catalyst. So yeah, that's really it. We form the catalyst. Let me just go over the notes I wrote. Oh yeah, reaction to equilibrium, so you cause stress to the system. We're gonna remove the water that's formed. I mean, water is formed where? Like here, right? Water is formed. This. Oh, I didn't show it. Oh, that's why I was bugging. Okay, water leaves. Yeah, I should have wrote it. So the fifth step. So if we were like 1, 2, 3, 4. Um, and this is step 6. Step 5. I mean, I didn't write it, but it leaves, right? This would leave. So if we were to write it like this, like special for it, that's not how you write it. Like this, right? Yeah. So we're gonna have this. This is gonna end up leaving, and that's step 5 and step 6. Um, okay, beta carbon, yeah, initial protonation. We're gonna initial protonation will be where like where would you prefer the charge to be? Is we're gonna prefer it to be on. I mean, we were talking about it here. We'd prefer it to be there because it's delocalized right there. Okay, yeah, that's really good.